Alright, so this is the last page of the practice test, question 4. Cobalt metal is oxidized to cobalt plus 2, so it gives us a hint right here, this is going up in charge and oxidized, by the nitrate ion in the presence of strong acid. Nitric oxide gas is one of the products. Answer the following questions. The table of surf table right here might be helpful. So first of all, the cathode reaction. So the cathode reaction, remember, is the one that's reduced. And so it says cobalt metal is oxidized, so it's not going to involve cobalt metal, so it must involve the nitrate ion. And the nitrate ion, if you forgot, is NO3-, which of course could be on the back of your periodic table. And it's in the presence of strong acid, so we are definitely going to have the availability of H pluses in case we need it. And then it says nitric oxide is one of the products, and it makes sense that nitric oxide would be in the cathode half reaction because nitrogen is going to have to be changed from a, in this case, positive 5 to a positive 2. And that's our reduced piece. Now, you could also look on the standard reduction chart right here, and you could find this half reaction of nitrate ion right here going to NO right here, and that half reaction could simply be copied right off of the E chart right here onto a question like that. I'm going to go ahead and balance the half reaction by using the half reaction balancing steps, just so you can see how it's done one more time. Balance everything except for hydrogen and oxygen. Balance the oxygens with H2O, so plus 2 H2O right here to get 2 more oxygens. 2 plus 1 is 3, which gives me 3's right there. Balance the hydrogens with H+, so I have 4 hydrogens right here, so I'll need 4 H pluses right here. And then balance the charge with electrons, and since I have positive 4 right here, and I have 0 right here, that means I'm going to need 3 electrons, I believe, because that gives me a 0 on this side and a 0 on this side. And just to check, I can see that that's the exact same reaction that's right over here as is written right here. Let's see, in the anode half reaction then, it says cobalt metal, so that would be CO, is oxidized to cobalt plus 2, and so that's my oxidation anode half reaction. Remember, anox, so that's how you can remember what anode is and what oxidized is. And so then to balance this, I need 2 electrons right here since everything else is balanced. Now, to get the overall balanced equation, the last couple steps I'd have to do is to balance the electrons. You'll notice that there's 3 electrons in this one and 2 in this one. And so I'd end up multiplying this reaction by 2 and multiplying this reaction by 3 to get the electrons equal, and I'll rewrite those reactions down here. So that would give me 6 E minuses plus 8 H pluses plus 2 NO3 minuses, arrow, 2 NO plus 4 H2Os. And then right here I'd have 3 COs going to 3 CO positive 2s. Whoops, write the 3 in there. And then I'd have 3 times 2, or 6 electrons. And now to get the total reaction, I'd notice that my 6 electrons would cancel right here, and everything else would end up being on both sides of the reaction. So 8 H pluses plus 2 NO3 minuses plus 3 COs, arrow, 2 NOs plus 4 H2Os plus 3 CO positive 2s right here. And that would give me my overall balanced redox reaction. I should check it for charge and for mass. And so 8 positives and 2 negatives gives me positive 6 on this side, and I have positive 6 on this side. 3 cobalts, 2 times 3 is 6 oxygens. So I have 4 plus 2 oxygens here for 6. 8 hydrogens and 8 hydrogens, and 2 nitrogens and 2 nitrogens. Bingo. Last one, number 5, aluminum metal is oxidized, so my anode half reaction will be aluminum going to aluminum plus 3, by hydrogen peroxide in the presence of a strong acid, so once again I'll have H pluses available. So my H2O2 then is going to be my cathode half reaction. If you're not familiar with H2O2, now is the time to become, because this is the one exception where oxygen is going to be in its -1 state. You very, very rarely see hydrogen peroxide, but when you do, you see oxygen in its -1 oxidation state. Cathode half reaction means it's going to go up in oxidation. I'm sorry, it's going to go down. It's going to be reduced because it's the red cat. And the state that oxygen loves to be in, if possible, when it's reduced, would be -2. I'd advise looking on here and seeing if you can find those half reactions. So aluminum is real easy to find, and we have that half reaction. Of course, we need to have 3 electrons over here to make sure the charge is the same. And remember, this is written as oxidation because an-ox, and so it will be the backwards of this reaction because these are all written as reduction. But then the H2O2 one, I think we could find that on here. Here's H2, here's the H2O2 right here. And then you can see that it makes water over here on the right-hand side as your product. And then you can see that the H2O2 also has 2 H pluses right here. And you can see that 2 electrons are transferred when that happens. And so there, with a 2 in front of here, is my balanced half reaction. Then we can take these balanced half reactions right here, and we can combine them to make the overall balanced reaction. All right, more soon.